Hello, you guys. So today we're going to talk about fractions, specifically equivalent fractions. We're going to take a look at some examples of what makes an equivalent fraction. And so the first thing that I want to do is I have bear with me here, a dry erase board. So when we look at the word equivalent up here, what comes to mind as another word that's similar to this word, equivalent? What's another word that's similar to that? If you were to guess the word equal, then you would be correct. So an equivalent fraction is really just two fractions that are equal to each other. So what's a fraction? Let's review. So let's take a look at this box here, where you have you have a box that's split in half, and you have two separate pieces. One piece is shaded, and the other piece is not. So, like I said, you have one box that's split into two equal pieces. So the two here is represented by the denominator. Two pieces that make up this whole. And out of these two pieces, you only have one that's shaded. That's represented up here by the numerator. So this is a fraction of 1 over 2, or 1/2. Now let's take a look at some of these examples down here that I have. If you take a look at this first one here, this circle here is similar to this box where it's split in half. One side is shaded, the other is not. So you have that same 1/2 fraction that you do up here. This could be a pizza, a pie, or something. But let's say it is a pizza, and let's say you were splitting it. 1/2, or this piece 1/2 goes to your friend, the other piece goes to you. You have two pieces. You both get 1 and 1. So let's say you and your friend decided to split it up into 4 separate pieces. Well, the shading part, as you can tell, has stayed the same. The only thing that's changed is the number of slices. The number of slices is now 1, 2, 3, 4. So it's no longer, the denominator is no longer 2, because now you have more than 2 pieces. See, now you have 4 pieces, so the denominator here is going to be 4. So let's write that down. And so now you can see that here the denominator is 4. So out of those 4 slices, how many are shaded? 1, 2. So you have 2 out of the 4 shaded. So your fraction is now right over there, 2/4, which is equivalent to 1/2. The shading, as you can see, has stayed the same, but the number of pieces has changed, so your numerator and denominator has changed, but the fractions are equal. Even though they look different, the fractions themselves look different, they're still equal. And that's important to keep in mind. Let's take a look at another example down this way. So you have a shape here with 4 different pieces, and of those 4 different pieces, you have 1 shaded. So you have 1 over 4. 1 shaded for the numerator, and then 4 separate pieces for the denominator. And then if you take a look at this one here, you have 4 on top, 4 boxes on top, 4 boxes on the bottom, for a total of 8 pieces on the denominator. How many are shaded? 1, 2. So you have 2/8. These 2/8 are equal to this 1/4. As you can see, the shaded piece has stayed the same. The only thing that's changed is the number of pieces here. The pieces have increased, so the numerator and denominator had to change, but they're still equal to one another. The shading, like I said, has stayed the same. Now let's look at this last one here. You have 16 pieces and 4 shaded. So you have 4/16. And like I said, the shading piece consistent on all 3. The only thing that has changed is the number of pieces. So these are all equivalent: 4/16, 2/8, and 1/4. They're all equivalent fractions. So for this lesson, we're going to be taking a look at these examples along with others about equivalent fractions. Thank you.